A common error that I have found with the geoboards, when looking at this right triangle, assuming that since this side length is 1 and this side length is 1, that this diagonal side length is also 1 because it goes from just one peg to another. Let's explore this a little bit further. In middle school, students will dig into the Pythagorean theorem and how this applies. However, I want to make sure that you understand whenever you see children use geoboards and say that that side length is 1, that that's not actually 1. So if we label this side length as 1 and this side length as 1, we have to think about our Pythagorean theorem, which states that a squared plus b squared equals c squared. So a squared, if this side is a, this side is b, then this side will be c. So if a is equal to 1, 1 squared, 1 times 1 is still 1. And b squared, 1 times 1 is still 1, which would be equal to c squared. So 1 plus 1 is 2. 2 is equal to c squared. And that means that c is going to be equal to the square root of 2. The square root of 2 is a little bit more than 1, so it's not exactly 1. Why is it important for us to pay attention to those slanted or diagonal lines on the geoboard? Well, let's see what this might look like if your child was asked to create another shape. When looking at this new figure, a student might come around and count this as 1, 2, 3, 4, 5, 6, 7, 8, and then they may see this distance as 1. So they may say that the whole perimeter is 9. But remember that the perimeter right here is not equal to 1. So that's going to be a little bit more complex for elementary school students, which is why in elementary school we stick with rectilinear figures. And remember, rectilinear figures are figures that have only right angles, because when you have something that's not a right angle, you're going to have to bring in the Pythagorean theorem in order to find the side length.